Chemistry Summary by Thomas Ziegler. Unit 1, Atomic Structure. The periodic table. In the periodic table, elements are arranged from left to right and top to bottom, arranged by expanding atomic number. The rows are called periods. The period number of an element signifies the highest energy level an electron in the electron possesses. The quantity of electrons in a period increases as one descends the periodic table. Elements that occupy the same column on a periodic table are called groups, and they have identical valence electron configurations. The periodic table is important because it is organized to provide a great deal of information about elements and how they relate to one another in one easy-to-use reference. Unit 2, Nuclear Chemistry. Nuclear power. Nuclear power is a zero-emission, clean energy source. The nuclear reactor houses the fission process. The fission process generates power by the process of splitting uranium atoms to produce energy. The heat released by fission is used to create steam that spins a turbine to generate electricity. Additionally, because they do not produce greenhouse gases, nuclear plants protect air quality and mitigate climate change. But the downside is the cost of the plants, which is around $6 to $9 billion. Unit 3, Electrons in the atom. Static electricity. Static electricity is the result of an imbalance between negative and positive charges in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. One way to discharge them is through a circuit. If you rub one object against another, it can transfer electrons. For example, if you rub a balloon against your hair, it can stick to the wall seconds after due to static electricity. Another example is rubbing your feet across a carpet, then touching a doorknob after, creating a shocking effect that you will experience. Unit 4, Chemical bonding. Sports drinks. Sports drinks such as Gatorade and Powerade use ionic compounds to prevent water intoxication in athletes by maintaining a normal concentration of electrolytes. Electrolytes are chemicals in your bloodstream that regulate certain bodily processes. They are lost when you sweat and must be replaced in the foods and drinks that you consume. They are both positively and negatively charged ions. For example, calcium, chlorine, potassium, sodium, and magnesium. Unit 5, Chemical reactions. The Statue of Liberty. The Statue of Liberty is made of steel and cast iron, but the majority of it is made of copper. The reason it is now the color green is because that the copper that it was originally made of was exposed to the air with carbon dioxide to make copper carbonate, which is creating a greenish color over time. The reaction type for this phenomena is called oxidation, which is the result of an object being exposed to oxygen. Also, this reaction is called corrosion of copper, as seen by the equation and pictures below. Unit 6, Stoichiometry. Cooking and baking. A recipe is just like a chemical equation because they both give information and have the same amount of elements on the reactant side and product side, just in a different form. For example, to make a sandwich, if you need 2 slices of bread, 3 pieces of lunch meat, and 1 cheese, but you have 6 slices of bread, 12 pieces of lunch meat, 5 slices of cheese, you will get 3 sandwiches, 3 pieces of lunch meat, and 2 pieces of cheese left over. Given the cake recipe, and you have 4 sticks of butter, 5 cups of flour, 10 tablespoons of baking powder, 3 teaspoons of salt, 2 cups of sugar, 12 eggs, 10 tablespoons of vanilla extract, and 5 cups of milk. The ingredients that are limiting you to making a second cake are the cups of flour and cups of sugar, while you have everything else you need to make the second cake. Thank you for watching. Hope you enjoyed.